Hey, what's up? This is Anupam. Welcome back. This is the second tutorial on the video tutorial series on STM32F4Discovery board. You can check out my website www.logicvoltage.com. You can watch these video tutorials at the website also. You can even check out the video store at the website. It has some good video tutorial series there with a very attractive price. A lot of people are buying it. You can also get them and learn some very awesome things about embedded programming. And I'm sure you'll not be disappointed if you buy them. You can get in touch with me also in case of any inquiry. Just go to contact us page and fill up the form and I will reply. You can check out the forum also. For any tutorial related queries or any technical questions, you can just register yourself on the website and then create a new topic on a forum and write your questions and doubts, and I will reply back there so that other people can also see the comments and what discussion is going on. Please make some donations so that we can continue to make the tutorials free for you. You are welcome to choose any amount as you like for donation. It will be highly appreciated. Thanks. Okay, so now in the previous tutorial, we have learned basic concepts about microcontroller, ARM programming, and also gone through the features of STM32F4Discovery board. We saw how the Atomic True Studio looks like after installation. We ran the demo project also on the Discovery board. So now in the tutorial, we will continue further. Okay, so now to program any microcontroller, we need to have its datasheet. A datasheet is actually a document where you will find all technical details about the microcontroller, like its register names, memory addresses, how to start functionalities like ADC, GPIO, timers, SPI, USART. So in STM32F4Discovery board, we have STM32F407VG microcontroller. And to start programming on this microcontroller, we need to grab its datasheet first. You can easily get its datasheet from ST website or just type reference manual of STM32F407VG on Google and search it and you will easily find a PDF. Or you can go to www.logicvoltage.com and click on downloads here, like you can see in my screen. And here you will find all the data sheets. Click on this top link and you get the PDF. Just download and save the PDF somewhere in your system. I have already downloaded that. Let me open that. You can see in the screen now that the reference manual is now opened. This sheet is will be required on almost every future tutorials of STM32F4Discovery board. In this sheet, everything about the microcontroller is written. Now, how to read and understand this sheet, and that I will show you later. For now, just save it somewhere in your system. Okay, so now we have the data sheet. We have already installed the Atomic Studio. So now we are ready to start writing our program. The first program that we will write is for LEDs on the Discovery board. We will create a program in such a way that it will switch on an LED on the board, and we have 4 LEDs on the Discovery board. We will pick any one LED and switch it on. Okay, so let's start. To do this, we need to first connect the STM32F4Discovery board to computer. Okay, so now I am connecting the board to computer. As you can see that LED started blinking. As I already mentioned in the previous tutorial that there was a demo program in the board which is causing these LEDs to blink like this. But that program is a bit more complex to understand for beginners, as it has many other things also. So now we will have to erase this demo program and write our own program to switch on an LED only and nothing else. Well, we don't have to do anything explicitly to erase the demo program. when we will write the new program, it will automatically delete the old program. Okay, now we have 4 LEDs here. We will just use one of them and switch it on, and there will be no blinking, as this is our first program. So we will try to keep it simple and easy. In future tutorials we will do much more with LEDs. Okay, so now we have connected the discovery board to computer. We can now start writing the code. Okay, we have opened Atomic True Studio to start writing code. If you have any prior experience in programming in any language, then if you look the Atomic True Studio, you will find that it's kind of having a similar looking interface like we have any other IDE available for other kind of programming. Now to start our first program, we need to create a new project in the workspace. Workspace is the directory where all our projects will be saved. So let's start. Let's create a new project named First LED Program. Let's do that. Right click on the left side on this project explorer, then click on new, then click on the C project. Okay, so now here we have to type the name of our project. Let's give it First LED Program. And select embedded C project here, then click next. Okay, so now it's asking a lot of options like which microcontroller or company we are using here. So let's start from the first is from vendor. We have ST Microelectronics company. We have to select this because our STM32F4 Discovery board is from this company. So select this as vendor. In the evaluation board section, we could select STM32F4Discovery, but right now I'll keep it none. I'll tell you why I did that in later. In microcontroller family, we have to select STM32F40XX F1XX devices. This one, as you can see. And in the microcontroller, we want to select the microcontroller that we have on the STM32F4 Discovery board. That's STM32F407VG, this one. And rest we have to keep it by default. Then click next. This also we have to keep it by default. Click next. Okay, here we have to select the ST link because we have debugger ST link in our discovery board. Then again click next, then finish. So it's now building our project, our first LED program project. It's building it. Okay, so now it's done. Please try to remember these steps for creating a new project, as in future tutorials also we'll create many new projects, so at that time I will be skipping some details. Okay, so now on the left hand side window you can see that our main project has been created. The root folder First LED Program is the name of our project. Then we have few folders in that: binaries, includes, libraries, so src. Then we have few .c and .h files in the source folder, then debug folder, and finally a .ld file. Now what individually these folder means is that I will explain later. For now just keep it that way, and our main attention should be on the src files. Here src means source. You can see that we have main.c in the source directory, and the file is also opened here by default. We will write our first program for LED is in this main.c file itself, and we will compile and build the whole project. If you know about C programming, then you already know that every program starts from the main function. You can see that in the main.c file there is already some code written when we first created the project. For now I am just deleting the comments so that the file looks clear. Okay, now we have an include file and a main function. In the main function, we have an integer I declaration and a while loop. Okay, so now our main goal is to switch on the LED on the discovery board. But before we go further, you first have to know about what is logic 0 and logic 1. Okay, so we need to understand what is logic 0 and logic 1. If you are familiar with computer technologies, then you probably know that computer always works in binary, which is 0 or 1. So similar is the case here. Our microcontroller works in binary. So here logic 0 means 0 voltage, and logic 1 means 3 voltage. Because in this discovery board, our microcontroller is currently working on 3 voltage. So that means if we give 3 voltage to microcontroller, then logic 1 will be equal to 3 volt and logic 0 will be equal to 0 volt. Okay, now let me draw a microcontroller. Now we have some pins here. Okay, and then we have a LED here. Now to make this LED switch on, we need to give 3 volt on the positive pin of the LED. And ground on the negative pin on the LED. That means we have to connect the LED positive pin to any one microcontroller pin and connect the other side of the LED to ground. This ground will be actually a common ground between the microcontroller and the LED, because in microcontroller also we have a ground pin. In reality, these two pins will be connected at the same point. Now we have all connections done. Now we have to tell the microcontroller to give logic 1 on this pin, which will be 3 volt on the pin, and our LED will be switch on. Okay, now we understood that we have to write a program that will make the microcontroller on the board to give 3 volt on the pin on which the LED is connected. Okay, now we have 4 LEDs on this board and we can choose any one for this program. Let's just take the green LED for our first program. Okay, so now it is decided that we will write a program that will make the microcontroller give logic 1, or in other words I can say that 3 volts on the green LED pin. But we have one problem here. As you probably guessing that we don't know our green LED is connected to which microcontroller pin on the discovery board, and that's where the datasheets comes in handy. To find out the green LED of the discovery board is connected to which microcontroller pin, we need to download the user manual of the STM32F4Discovery board. This we can get on ST website, or just go to Google search and type STM32F4Discovery and you'll get that in a PDF version. Or you can go to www.logicvoltage.com website and click on this downloads link on the left bottom side, and you can see in my screen, just click on this link and a PDF will be downloaded. Just download that PDF and save it somewhere in your system safely, as you will be needed that PDF in future also. Okay, I have downloaded already that user manual. Let me open that. Okay, so now you can see the manual. We downloaded this manual because we want to know our green LEDs connected on the board and in which pin on the microcontroller. So to find that, just go down to this user manual and find the LED section on page number 16. As you can see in my screen, now here you can see that we have 8 LEDs in the board. That's right, but user LEDs are only 4. The rest are used for different purposes. So we need to find the green user LED. As I highlighted, this is the green LED we are looking for. And this green LED is connected to PD12 pin on the microcontroller. If you can see that we have another green LED below. So don't get confused, that one is different. We need this upper one. Okay, so now we get to know that green LED is connected to PD12. Now let's get back to Atomic True Studio. Okay, now we need to write a program that will make the PD12 pin on the microcontroller to logic 1. And this will make the green LED switch on. We can start writing the program now. If you are familiar with a little bit of programming, then you probably know that our program will start from the main function. Okay, so let's start with my one line in this main.c file. This first line is already was written when we created the project. Hash include STM32F4XX.h. This is a header file. This first line is actually including the library. Well, if you already have a background knowledge about programming, then you already know about this. Actually, in simple terms, I can say that libraries are already built files where code is written and you can reuse it at any other file, so that you don't have to write the same code every time when needed. That's why we include the library files using these include statements. I will talk about this in detail in later tutorials, but for now just keep in mind that libraries are used to reuse the same code, or in short we call it write once and use many. Now next thing that comes in mind, that what code we are reusing here. Well, I will show that also in later tutorials. For now, just keep in mind that it's needed. Okay guys, the main goal here to light up the green LED. Now we need to know few things here before we go further. One is GPIO, General Purpose Input Output. In short, we call it GPIO. Well, to keep it short and simple, for now I can say that on every microcontroller there are some GPIO pins. Now we have a STM32F407 VG microcontroller in the STM32F4Discovery board. In this microcontroller we have total 100 pins around it, and most of the pins we can use as a GPIO pin. Now why we call a pin GPIO? That's because the pin can be used as a general purpose for either input or output. Like this, in LED program we will use the pin as general purpose output, or in other words I can say that I want the microcontroller to output logic 1 on the pin on which the LED is connected. Hence I will use the pin as GPIO. Well, actually we have many other options also other than GPIO, and on some of them we will work also in future tutorials. Now in any microcontroller there are many registers. Registers are actually some memory address, and each register has a specific purpose. Now registers are generally 8-bit, 16-bit and 32-bit. Now let's say that we have a 16-bit register. These 16 bits are actually representing some 16 pins on the in the microcontroller. Let's say that first bit is representing pin 1. Second bit is representing pin 2. Third bit is representing pin 3. And so on. Finally, on 16 bit is representing pin 16. So if you write logic 0 on register 1, then the pin 1 will output logic 0, or we say 0 voltage. And if we write logic 1 on the register bit 1, then pin 2 will output logic 1, or we say 3 voltage. This similar kind of philosophy is used everywhere in the microcontroller programming, and the same principle we will use in our program also. Okay, so now we know a little bit about GPIO and register and how they works. So same kind of process we will do here. We want the green LED to switch on, and we know the pin on which the LED is connected, that is PD12. So we need to make the microcontroller to output logic 1 or 3 volt on the PD12 pin so that LED will be switched on. So to do that, we need to find the register which represent this pin. And to find that, we need to go to the reference manual that we have downloaded earlier. Now you can see in my screen that PDF is opened. This is the reference manual of STM32F4Discovery microcontroller. Here let's go to GPIO section. You'll find that all the register names and every detailed information here. You can read here and get some more knowledge. We will go through on this in later tutorials, but right now we are trying to find the register name. Well, now we could have get the register name and work, but that's a bit difficult process. There is another and efficient way where we don't need to know the register name. That's because ST company provides the libraries. And as I mentioned earlier, that libraries are actually already written code which you can use it anytime. And in real world also people use the libraries. There are a lot of benefits of using libraries than just reuse the code, and you will get to know once we start using it. So in this LED program, we don't need to know the register. We will just use the libraries that are supplied by ST company. The libraries will actually do it whatever the values need to be set on registers. Okay, well, you actually don't have to do anything to get the libraries. That's because Atomic 2 Studio automatically put them when we created this new project. As you can see in the left hand sidebar that we have a libraries folder here. In there we have all the library files. We can use from them directly. Now just expand and you will find GPIO source files and GPIO header files. Just open them. You will find plenty of declarations and functions related to GPIO in these files. We will go through in detail in later tutorials, but for this LED program we will use only few things from these two files. Now you might be getting confused here or maybe didn't understand something, but don't worry, if you are new to hardware programming then it's normal. Some of the things you might not understand right now, but just go on with me for now, and in the end when we execute the program on the discovery board and saw the output, you will understand everything. Okay, so now there is one structure called GPIO init type def in the GPIO header file. You can see here we need this structure to set up some values. Let's declare that first in our main program. Now in this structure there are few things that you need to set. The first one is now with this line we are actually pointing to pin 12 as LED is connected to PD12 and 12 is the pin number on that port. To keep it simple, I can say that port actually is means of grouping the microcontroller pins. So we have port A, B, C, D, E in this microcontroller, and in each port we have 16 pins, and our green LED is connected to port D and pin 12. Now next thing is now with this line we are setting that we want the pin to be in output mode. We have four options to choose here: input, output, alternate function and analog. But we will be using the output mode here as we want the microcontroller to give output of logic 1 on PD12. We will go through on other modes on later tutorials. For now we will use the output mode. Now next thing is with this line we are telling that we want the pin to be in push-pull mode. We have one more option here, that is open drain mode. Now why we choose the push-pull mode and what is open drain mode? That also I will explain later in the tutorial. For now, just keep it this way. Now next thing is, now with this line we are telling that the GPIO speed, or in other words we say frequency. We have four options here: 2 MHz, 25 MHz, 50 MHz and 100 MHz. Now what is the role of speed here? That also I will explain later. For now, just keep it this way. Now we have set up the GPIO completely, and we just need to initialize it by calling this function and passing two arguments like this. Now with this line we calling a function named GPIO init. In this, the second argument, you can see that we are passing the structure that we defined, and the first argument is the port D, on which all these above parameters to be set, because our LED is connected to port D. Now with these 5 lines we have set up our GPIO port properly. Now we need to write logic 1 on PD12 pin. Now with this line we are writing logic 1 on GPIO port D and pin 12. Bit set means logic 1 and bit reset also means logic 0. We are setting the bit for pin 12 of port D. That means this line will make the PD12 pin to high volt, and our LED is connected to this pin, and thus the LED will light up. Now we are done here and we can build this code. But this code will not work. There is one more thing that we have to do. Before you can do anything on any GPIO port, you have to start the clock of that GPIO port. Now what is meant by clock, that I will explain later in the tutorial. For now we have to start the clock of GPIO port D, because we are doing all these things on GPIO port D to make LED light up. To do that we need this line. Now with this line we are enabling the clock on GPIO port D, hence our program is complete. Let's save this. Okay, we have written the code. Now we need to build this code and then transfer it to microcontroller on our discovery board. To do that, right click on the project name and click on build project like this. Now building will start and you can see logs in below console window. After build is complete, you will see something like this in the end. Hence our build is complete. Now we need to run this code on our STM32F4Discovery board. To do that, we go to run and click on debug like this. Now you can see that the appearance changed here. This is actually the debug mode. Here you can debug the code line by line, but right now we just want to run the code on the discovery board. So click on this resume button. Now the moment I click on this resume button, the code we have written will start running on our discovery board and our green LED will switch on. Now you can see the discovery board. I have already connected it to the computer. I still haven't clicked on the resume button and no lights are switched on. Now watch well what will happen. I am now clicking on that resume button. You can now see that green LED is now switched on. Hence our program worked. Great. Hence in this tutorial we have learned to write a basic program, worked on GPIO settings, and how to build program and how to run on the board. You can now click on the stop button here to stop the debugging mode and go to the previous mode like this. Okay guys, we have learned the basic things here. In the next tutorial we will continue this program, understand it in more detail, and then make this program in such a way so that the LED will blink. Once again, this is Anupam from logicvoltage.com, and thanks for watching. Bye.